Hi everyone, welcome to my channel again. Today we will be looking at test container, why we need it and what's the use case. Let's get started. If we go to the official documentation of test container is a latest technology that is very useful in testing areas. We want to test a real database. If you don't want to mock anything, it's maybe database or it may be other container that is being deployed to Docker. So we can use test container to test all integration and end-to-end testing. So if we check, test container is a project that itself is a Java. Test container is all written in the Java. The core of the test container is on Java. So if we check the GitHub repo of this one, there are multiple other repos that are available using the test container. So if we want to use a test container in a Go applications, we also do have a Git repo and two supports. Similarly for .NET, Node, Python, and others are also there. So test container is very useful when you do integration testing and end-to-end testing with real database or real services if you are not mocking with anything. Today we will be looking test container with JUnit 5 and Micronaut application. So in today's video, I will be showing you test container integration with JUnit. However, in the next video, I will be showing you in Micronaut, they do have a native support for test containers. So today is just, I will show you how we can use JUnit with Micronaut and test container. But later we will remove the JUnit with test container and we will use a Micronaut native support for test container, which gives us more flexibility in terms of native test compilation. So if you are working with native using GraalVM, then the Micronaut test libraries will help us in that context more, because when we run a test container native support test into a GraalVM, Micronaut has inbuilt supports for all those things. So just today we will be using a JUnit 5 integrations. So if we go to a quick start, we do have JUnit 4, JUnit 5 and Spock test. We will be use JUnit 5. Let's see what we need to add in the build.gradle to use the test container. So I have a Micronaut application. So if you check my project structure, it's a clean architecture that the videos that I have done in the previous, I will put a link in the description. So this is a clean architecture project structure, API core, infrastructure, and share. So these are all Micronaut application. So I'm using my Micronaut latest version. So if you check, it's a Micronaut version 3.6.1. So in the API, so I'm not writing any test case for core, infrastructure, and share. So you can still write unit testing for that one. But since I'm covering everything with the functional test, with the integration test, that's why I'm not writing any unit test case for this share project, infrastructure, and core project. So all my test, functional test belongs to all business logics on core, infrastructure, and share are all done in the API layer, because API layer is the top layer that communicates. So every test case is written over here. So if we check the build.gradle, what we need to add for test container using JUnit, so there is a test implementation org test container for that one to integrate. So you need to add this org test container JUnit Jupyter to support the test container using JUnit. So that's the only dependency we need to add, and its scope is like test implementation. So this will be only used when we are running a test. It won't be used in any other things. That's the scope of that. And we see what we need to add to run a test container. So in my project, this is a full project that integrates with MongoDB and it has CRUD operations. So it's a full applications so that has occurred operations using the MongoDB. So I am using a MongoDB to test all the applications, logics and everything, end-to-end testing using a Docker. Just to remember, if you are using a test container, you need to have a Docker, because test container runs on Docker. So that's the main part of the test container. So we need to have a Docker for that. So this is the only code that we need to use to integrate with test container. So if we check, we have a life cycle because we want each test case to use the instance. That's why we have test instance. And one of the annotations is test container, because we are using a test container and we are telling every test case to use the test container to run our test. That's the annotation for this one. And this is the class that I have created. This is the abstract class that implements test property provider. This is from the Micronaut test property provider, because if we check the application.ml over here, the MongoDB URL is something that we're gonna change in the production or dev environment on this one. So in the test container, when we are using, this is not the Docker instance that is supporting, because the test will run randomly on the different port. So the Docker image of the MongoDB will be on different port every time when we run. So when we run the test, we need to map the Docker that has using the test container with that port and host in our application. For that purpose, we have a test property provider. So again, because I'm using a JUnit integration with test container, but if in the later video I will show how we can refactor this code even further, because we don't need a test property provider if we will use Micronaut test container feature, because they do have support for test container features, and if we are using that features, we will not require this code. This is just how, without the test container libraries of Micronaut, how we can use a JUnit with test container. We are using a generic container. This is from the test container. Let's see. So if we check the source, it is coming from the test container. So this is the generic container. Then we need to get a image. So we need to have a Docker knowledge as well, because Docker works based on the image tags. So this test container, if we check, we are using a Mongo latest tag. So in the Docker hub, if we check, we do have a MongoDB latest. So let's check on the Docker hub. So if you go to Docker hub, so let's search for here MongoDB. So see over here the latest tag. If we are using a MongoDB latest tag, it is gonna use the latest version of MongoDB. That's how it works. So we are getting a Mongo container over here, and we are saying a Mongo container to start from here. And see, we do have a with reuse command as true. What does this mean? Because each time when we run a test container, the each test case not gonna create a new instance of MongoDB. So it's gonna use the existing Mongo that is been running on the test container. For that purpose, we are using with reuse. If we make this false, it's gonna create each time each MongoDB Docker instance on the test container. So for that purpose, if you don't want to create a multiple instance of MongoDB, so we can set this flag. And because the MongoDB on the local instance, we have 27017, that's the default port for MongoDB, and we are exposing that port, and we're gonna map that port with the test container port. So if when we run the test container in MongoDB, it runs on the random port. So we want to map that random port into this, because in the test container in the Docker, the MongoDB runs in 27017 port. So we want to replace that 27017 port with our random port. For that purpose, we have this property, and if we check the map of this mongo.uri, this is we are replacing this URI, because over here we are saying either get a Mongo host or local host or Mongo port, or either 27017. So when we run a test in test container with MongoDB, this Mongo port will be a random. It won't be a 27017. It won't be something random. So we want to get that random port and map to this URI, because our application is expecting a MongoDB is using this URI in when we fetch the data from the database. So for that purpose, we have to use we have to map the random port that's generated by test container, and we want to replace that random port with over here, so that our application uses that container to get all the data. So that's the only code that we need to integrate a test container with JUnit 5. So this test container fixer I have extended over here, and each because I have lots of business logics over here, that's why I have created different base fixtures, and that base fixture is extending a text container fixtures. But if this base fixtures is been used in many places, so if I have bunch of functional tests, these are all integration tests. These are not like unit tests, or these are not mocking, it is running on the real database. I mean real database means test container, Docker image, that's Mongo one. So each of my test case is extending this base fixture, and base fixture is extending test container fixture. Run and see how long it takes to start a container in Docker and run all our integration tests and finishes. So you might have a questions like, it's gonna start a Docker instance on Docker, then it will take a long of time, but it's not in the case. So and this takes like within a second, 2 or 3 seconds, is very fast. But remember, this is a test that is running without a native support. So if you run a native test, it will be more faster. If you run your test on GraalVM, when you integrate a GraalVM, it will be more faster than this. So let's see. I'm running all the tests. So how long it takes? So I have 101 functional tests. They are all functional tests. They are not any unit tests. They are all functional tests that is communicating with Docker, MongoDB that has been created, and fetching all the data and given. So it ran within a 2 second and 482 millisecond. So this is without a native. So if we run this again in the native, it will be more or less. It won't be even 2 seconds. It will be in some millisecond. So this is very fast. So if I run it again, let's see. So it's creating a Docker instance, is running everything on the Docker. I will show you. So again, if we check, it's 2 seconds and 456 milliseconds without a native support. In the next video, when I will integrate a GraalVM, because I will be creating a GraalVM with Micronaut support a video. On that video, I will show you again the same thing in the native. So we can compare the time 2 seconds 454 milliseconds with the native. Because I have already run on the native. It was on millisecond. It was not even in second. So this is very fast. So let's see. I'll show you how. So let's put a breakpoint over here, and let's debug this one, so that I can show you this test container is running. But before that, let me check the Docker for you, so that I can show you the Docker as well. So if you check my Docker instance, I have this one. So let's go to the event visualize, it will be more. So if you check I have SQL Server, console, Zipkin, and this is Kubernetes Minikube. So I have only 4 and only 2 are running, Zipkin and console. So there are no other containers. So I'm in the container. So there are no other container. So let me put a breakpoint over here and let's debug. So the breakpoint is over here. So if we check now the Docker instance, let's see again, this is just a command item. So if we check here, so we can see the Mongo latest. This is a test container. So this will create every time, see over here, test container, and this is Mongo latest. The test container are using the Mongo latest. There will be a 2 Docker instance for each. So each time when we run the test case, this 2 will be created and this will get destroyed when your test finishes. So it won't be there after when your tests are completed. This is just during the time. So if we check the port of this, it's running on 57789. So if I check over here 57789 and let me put a breakpoint in one of the test cases. So after completing this one, I'll remove a breakpoint from here and continue debugging. So it came over here. If we check, still our Docker, so still those 2 containers are running. Show you by connecting to the database. So it makes you more believable that I'm not lying to you. So I have a breakpoint over here and the execution is over here in one of my test cases. Should get the latest list of vendor. So if I again go back to the test container fixer, so I was using this test container get map port 270017. That's the default port of MongoDB. So we are replacing that one. So if we execute that one again, so we can see port as 57789. Yes. So let's me connect this one in the database. So I'm using a data grip to connect to the MongoDB. That's the container. That's a running over here. This is a container. Remember, if I execute everything, the test fails or pass, this will blow away. It won't be here. I'll show you later. So I will connect this one. So this, I'll name it a test container, and we're gonna replace this port by 57789 because that's the port. Let's that's the port I'm using, 57789. Let me check again. 57789. Yep. So let's apply and okay. So it's connecting to that test container. So it's connected to that container. So if you check, I have a Fatty Bird product. That's the schema I had over there. So I have a collection of 2, product and vendor. So let's me complete this one and I'll show you. Remove the test, debugging, and continue on this one. So all my test has been passed again. So let's check the container first. See on the container, that's it's not there. So all my tests passed. So after a few seconds, this all goes. So let's try to run it again with the debugging on the same place. So if I put a debugging over here, this time we will get some different random port. So my debug is over because some of the other test case is already in pass because this test case on that one. So if we run again this thing, we will get some different port. So previously 57789 was the port. So now we can see 58769. That's a different port it is running. So again, if we connect to that again on this one, those two will be there. So that's how we do our integration test on this test container, and it is very fast. So it won't even take more than 5 seconds. So it's 35 seconds because I was debugging. If you run it again, it won't take even more. So that's the use case of test container, because it's we are not mocking any database, and we are not if you have a service, if you are using microservice and if you are deploying different service on different container, we can also make those container available in the test containers. So we can also use that one. It's a very good feature. In the next video, I will show you how we can use test container with Micronaut native support for test containers. With that, we don't need to write even this code, so we can refactor, and Micronaut test containers has support for native compilations of test. So thank you.